Alright, we are going to go through the multiple choice section of the 2017-2018 Math 7 Common Assessment. So I'm going to go through, I'm going to solve the problems, kind of give some explanation, and share the answers. Alright, number 1. In Mr. Carraway's second period class, there are 8 students with blue eyes and 11 students with brown eyes, 6 students with gray eyes, and 1 student with hazel eyes. If Mr. Carraway selects one student at random, what color eyes is the student most likely to have? Okay, first thing I know is that I want to look for the most common one, and that's definitely going to be the largest number. So the most number of students have, not 11 eyes, that would be weird, have brown eyes. So if Mr. Carraway just randomly picked someone, the most likely answer would be that that student would have brown eyes. Alright, cool, moving on. The table below shows the proportional relationship of the height of a plant over a 4-week growth period. What is the constant of proportionality? K, the rate at which the plant grows each week. Alright, so I want to see if I can just notice a relationship right here. I can also use my star reference chart if I'm kind of struggling and I don't remember. Always go look at your star reference chart, even if you're pretty confident. It will take you half a second to just glance over and be like, yep, okay, I remember. So I got K equals Y divided by X. So I can pick any one of these Y's and divide by X. Let me choose, I'm going to choose this one. Any one of them should give me the same answer. Y is 6 divided by 4. Well, let's see. I know I can simplify that before I even start dividing. I can divide them both by 2. That's 3 halves. Maybe I already recognize, oh, I know that 3 halves is 1 whole and 1 half, or 1 and a half like that. Ooh, there's my answer. H. Alright, moving along to the next one. The first few questions in the common assessment shouldn't take us too long. It's the ones towards the end that I'm banking my time for. Alright, Quentin's mom made a stop to pick up breakfast before dropping him, whoopsie, and his little brother off at school. Quentin ordered the large egg and potato burrito, but his brother ordered the regular chorizo burrito. Okay, before I even read, I just want to go see and make sure I have that information. Egg and potato, the large one, and his brother ordered the regular chorizo. Okay, cool. The cashier charged Quentin's mom 82 cents in sales tax. That's added on in addition to the cost of my burritos. And his mom gave the cashier a $20 bill. How much change did she receive? Okay, before I start working on that problem, I'm going to try and figure out how much she had to spend. So, the regular chorizo burrito, the large egg and potato burrito. Make sure that I match my decimals up so that I'm adding the proper place values with each other. 9 and 9 is 18. 4 and 4 is 8, plus 1 is 9. Decimal point. 4 and 5 is 9. Don't forget my sales tax. I don't have to calculate it. They already gave it to me. That's nice. Okay, so with tax, Mom had to pay $10.80. She paid with a $20 bill. I'm going to add the decimal point in the 0 cents, just so that I have the same number of place values going on. And then I'm going to subtract so that I can see what she gets back. 0 take away 0 is 0. 0 take away 8, not going to work. I'm going to have to go borrow. Not from there, from here. Regrouping, that gives me 10. Oh, but I still need to borrow. Again, 10 minus 8 is 2. Decimal point. $19 minus $10 is $9. So she would get $9.20 back. Next up, a pair of Jordans. Uh-oh. There we go. A pair of Jordans originally priced at $200 are on sale for $175. I drew all over that. What does that say? By what percent was the price of the Jordans reduced? Okay, so it originally cost $200. It went down to $175. I can tell that that is $25 off. Because if I added 175 plus 25, it'd get me back to 200. So I want to figure out what percentage that is. There are a few answers I can eliminate right away. Like, it wasn't 25% of 200, it's $25. And those are two different things. 25% off of 200 would be $50 off of it. That's not right. This seems way too high. It was not a huge decrease. 87% would be more than $100 off because it's more than 50%. That is unreasonable. So now I've already eliminated it down to 2 answers just by thinking about what's reasonable. I'm definitely going to solve it through, but at this point, if this was like the last question or something, or you really didn't know, at least you've narrowed it down for when you're guessing, you have better odds. Okay, let's see. We can even try and logic through these. Well, 10% of 200 would be $20. Okay, so that's $20. We need another $5 to get to our 25 that we reduced by. Well, let's see. If that was 10%, then 5% would be half of that. So 15% would be $30. That's not right. So it must be this one. There are other ways to solve it. You could have solved it in a proportion, but you can reason your way through if you are comfortable with your benchmark percents as well. All right, number 5. Marcus spent 624 minutes in the studio recording 52 songs. Each song took the same amount of recording time in minutes. How long did it take Marcus to record the first 20 songs? All right, so I am going to solve this one with a proportion. I'm going to say 624 minutes to 52 songs is equal to, because it took the same amount of time for each recording of each song, some number of minutes that we don't know yet to 20 songs. Okay, looking side to side, I don't immediately see a scale factor to get me from 52 to 20. Looking up and down, and I'm looking from 52 to 624 because I want to always be going towards my unknown. I don't know that one either. So, I'm going to make life easier for myself by simplifying this, and then maybe I'll get to a point where I can recognize the relationship a little more easily. This ends in a 4 and this ends in a 2, so even if there is a larger factor, if you see it, great. I like to start just by dividing by 2 to see where I get. Half of 52 is going to be, well, let's see. 52 divided by 2, 2 goes in 2 times, with a remainder of 12. Okay, 26. Half of 624 is going to be 312. Still not seeing a relationship, but guess what? That's even, that's even. I can divide by 2 again. Half of 26 is 13. I'm going to try not to write all over my answer choices. This might be the time where you want to either go off to the side or pull out that grid paper to give yourself some more space. Half of 312 is, let's see, 156. Oh my goodness, I'm still not seeing that relationship. Well, okay, I could try to divide this again. Let's see, no longer even. 3 plus 1 is 4. Okay, that's not divisible by 3. So I might at this point just actually divide this out and see if it simplifies down to a whole number. 13 goes into 1 0 times. 13 goes into 15 1 time. So those questions that we solved earlier that didn't take us so long, good thing we went through them quickly because now I can feel comfortable having a little more time for this. Ooh, and it does Yay. Okay, so if I divide by 13 here, I get down to 1, and 156 divided by 13 is 12. Oh, don't end there. Don't get tricked. That's not my answer. I now have to scale back up. 1 times 12. Oh, that's not right. 1 times 20 is 20. 12 times 20 is going to be 240. What are my units? Minutes. Don't see that anywhere, but these units are in hours. Goodness, this is a long problem. 240 minutes. How do I change that to hours? Well, every hour has 60 minutes. So I'm going to divide this into groups of 60. I'm going to make my life a little easier. I know that I can divide these both by 10. Okay, now I have 24 divided by 6. Oh, I know that one. That's 4. My units are hours. Please, where is it? Oh, hooray. I wrote all over it, but it is D. All right, number 6. Alexa's driving to her teammate's house. The scale on Alexa's map is 1/4 of an inch, which is equivalent to 3 miles. The distance between Alexa's house and her teammate's house is 1.5 inches on her map. What's the actual distance in miles? Miles. Okay, yep. Between Alexa's house and her teammate's house. Okay, so on a scale, 1/4 of an inch equals 3 miles. This one's in decimals, so I'm actually going to change this to decimals. 1/4 is 25/100ths of an inch. I want decimals because I like them better. I think they're easier for me. If you like fractions, go ahead and change that to 1.5 or 1 2/4 to make it equal, or to have common denominators. Okay, so I want to get from 25/100ths of an inch to 1.5. Well, let's see. I know that 4 groups of 25/100ths equals a whole, and 2 groups is going to be 50/100ths. So in total, I need 6 groups, or times 6. 3 times 6 is 18. It's going to be 18 miles between Alexa's house and her teammate. Moving on to, nope, not that page. Number 7. A motorcyclist travels at a speed of 35 kilometers per hour. Which representation does not, very important word, show the distance that the motorcyclist can travel at this rate? Alrighty, let's see. So, 35 kilometers per hour. That is going to be a multiplicative relationship. So if I wanted to say, oh, look, I'm seeing D and T. I bet this stands for distance and time. Okay. Oops. Miles dying. Gotta pause quick so I can, alright. Oops, sorry about that. Okay, so I can see distance equals 35 times time. Yep, that seems like it would be reasonable. That's not my answer, though, because I want the one that's not showing it. 1 hour, 35. 2 hours, 35 times 2 is 70. This looks good. Okay, yay. Showing the relationship. Boo, not my answer, because I want the one that's not showing it. The motorcyclist can travel 105 kilometers in 3 hours. Well, I already thought that this one worked out. 3 hours, 105 kilometers. That seems true. Alrighty, let's see. 1 hour, 35 kilometers. Yes. 2 hours, 70 kilometers. Yes. 3 hours, 105. Yep. 5 hours, 140. Let's see. Oh, no. This is my answer because this one is wrong. 140 represents 4 hours, not 5 hours. Moving along. Luis and Carla each invest $500 in separate accounts. Luis invests his money into a simple interest account. The account has an interest rate of 3%. Carla invests her money into a different account. The account earns 3% compound interest at the end of the year. Whose account will have more money at the end of 1 year? Okay, well, let's see. $500. He invests in a simple interest rate of 3%, I'm assuming, for 1 year. Okay, so He had $500, 3%, well, 1% would be divided by 100, $5, times 3, because it's 3%, $15. Okay, so Luis is getting the $500 he already had, plus $15 that he's earning at the end of the year in interest. So Luis has $515. Carla invests her money into a different account. The account earns 3% compound interest at the end of the year. Okay, well, good for Carla. Compound interest at the end of 1 year means that she's going to get 3% of 500, but it's only compounded at the end of the year. So compound interest would be great if she was lasting for more than, if she kept it in there for more than a year. But right now she's also getting the 3% of the $500. So she is also getting $515 at the end of this year. So both of them are getting the same amount. If they keep it in longer, Carla's compound should get her more interest. But right now, not so much. So Luis will earn $15 more in interest in his account than Carla at the end of the year. No, they're each earning $15. Carla will earn $15 more in interest than Luis. No, they're each earning $15. There's not enough information provided to compare the two accounts. I don't think so. Both accounts will earn the same amount of interest and will have the same balance at the end of 1 year. Yes, if this was talking about more than 1 year, then no, they'd earn different amounts. But since we're only talking about 1 year, they each earned $15. All right, moving on to some cookies. Hannah is baking cookies for her church bake sale. She can bake 16 cookies using 2/3 cup of cookie dough. Ooh, yummy. If she uses a total of 4 cups of cookie dough, how many cookies did she bake? All right, this one seems like I can solve it in a proportion as well. 16 cookies to 2/3 cups of dough. If she actually uses 4 cups of dough, how many cookies? All right, well, let's see. 2/3 times what equals 4? Let's see. 2/3 times something equals something that will probably simplify to 4/1. Well, what could that be? Well, if I can't think of it right away, another option is for me to say 4 divided by 2/3. That'll give me that missing fraction right there. I can change that to a fraction. Keep my 4/3. Ignore the spam phone call, because we're doing math. Keep my 4/1. Change. Flip. That gives me 12/2, which this is, remember, division. 12 divided by 2 is 6. Okay, 6 groups of 2/3. Let's double check it. 6 times 2 is 12. 12 divided by 3 is 4/1, or 4. Okay, cool. Got my scale factor. Times 6. 16 times 6. It's probably not going to be 32. That's times 2. That's too small. My guess is it's going to be one of these just because we're looking at larger numbers, but I'm actually going to do it because I don't want to guess at this point. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. And our answer is B. Cameron decided to get an early start on Christmas shopping. She's already purchased gifts for her brothers and sisters. She has 60 square feet of wrapping paper. She needs to use 7.5 square feet of wrapping paper for each of the gifts. Which equation could be used to find W, the amount of wrapping paper left over after wrapping G number of gifts? Let's think it through. Okay, she's starting with 60 square feet. When she wraps a present, she's not adding that wrapping paper to the roll. She's taking it away so she can wrap these pretty presents. So that's going to be subtraction. Every present uses the same amount of wrapping paper. And we don't know how many presents, but they did tell us that we're going to call them G. Oh, we're calling them gifts. 7.5 square feet of wrapping paper for every gift. That's going to be multiplying. And we're taking it away from the original amount of wrapping paper she had. We're looking for an equation, and W is the amount left over. I think we're looking for something like this. I like to solve it myself first, and then go look, as opposed to staring at a bunch of equations and being like, does that make sense? Does that make sense? Because it's easier for me to think it through on my own. Okay, W, okay, got all our W's. We are not multiplying 60 square feet of wrapping paper times every gift. And it's easier for me to immediately be like, nope, that's wrong, because I've already reasoned it through. Over here, they're also trying to multiply 60 square feet times the number of gifts. We think that's wrong. We are also not adding wrapping paper to the roll. We're taking it away so we can find our answer that way. I'm going to pause here just to break up the videos, but I will record the next few problems in the next video.